Now question number 71. If a recurring decimal has a periodicity of 2, by what factors you multiply the variable equation to convert to a fraction? Here given that periodicity is 2. For example, 0.35 bar. Periodicity of a 0.35 bar is 2. Already we know here when the periodicity of a non-terminating recurring decimal is 1, then we should multiply 10 power 1. If the periodicity of a given fraction is 2, then we should multiply 10 power 2. If the periodicity of a given fraction is 3, then we should multiply with 10 power 3 and so on. Why we can multiply with 10 or 10 power x, 10 powers? What is the main reason here? The main reason is here, especially for cancelling the infinite decimal part. The main reason here for cancelling infinite decimal part. That's why we are multiply with 10 or exponents of 10. That is based on periodicity of the given fraction. If periodicity is 1, we can multiply with 10 power 1. Periodicity is 2, multiply with 10 power 2 and so on, like this. Now question number 72. Express the terminating decimal 0.35 as a rational number in its simplest form. 0.35, that is given here. Now we should express this fraction into rational form, that is in p by q form. Now count the digits in the decimal part. How many digits are here? 1, 2 digits. 1, 2. They are 2. Now for removing the point, the decimal point, we should keep, or when we are removing the decimal point in 0.35, the number of digits in the decimal part is 2. When we are removing the decimal point, we keep in denominator 1 after 2 zeros. When the decimal part having 3 digits, we can keep in denominator 1 after 3 zeros. When the given decimal having 4 digits, then we can keep in denominator 1 after 4 zeros, like this. Therefore 0.35 can be written as 35 by 100. 35 by 100. Okay. Now 35 can be written as 7 into 5. By 100 can be written as 20 into 5. Now 5 gets cancelled. It remains 7 by 20. Here 7 by 20 is the simplest form of 35 by 100. Okay. Now next question, 73. What fractional values does 0.9 bar equal, and why is this conceptually surprising? Here given that 0.9 bar, this can be written as 0.99999 and so on. let x is equal to 0.9999 and so on. What is the periodicity there? 1. Then we should multiply with 10 on both sides. So this gives 10x is equal to 10 into 0.99999 and so on. Okay, 10x is equals to 10x is equal to 9.9999 and so on. Say this number something 1. Now this is 2. Now we can do 1 minus 2. 1 minus 2. That gives 10x is equal to 9.999999 and so on. X is equal to 0.999999 and so on. Subtraction 10x minus x, 9x equal to 9.0. So x is equal to 9 by 9. So x is equal to, what is the answer here? X is equal to 1. Okay. The value of 0.9 bar is equal to, what is the answer? 1. Now next question, 74. Can the length of repeating block of a digits in the decimal expansion of p by q ever p greater than or equal to q? Already we know here, when any number is divisible by 2, any number is divisible by 2. Suppose any number is x, that is divisible by 2, then possible remainders 0, 1. When any number is divisible by 3, x is divisible by 3, then possible remainders are 0, 1, 2. When any number is divisible by 4, then possible remainders are 0, 1, 2, 3. When a number is divided by 2, the possible remainders are 0, 1. How many remainders we have here? 2. They are 0, 1. When a number is divided by 3, then number of remainders we have here 3. They are 0, 1, 2. When a number is divided by 4, then possible remainders are 0, 1, 2, 3. They are how many we have here? 4. Similarly, when p is divided by q, how many possible remainders we have here? Q minus 1. Up to q minus 1. Sorry. Up to q minus 1. How many remainders we have? Q remainders. They are 0, 1, 2, 3, 4, 5, 6 and so on. Q minus 1. Up to q minus 1. 0, 1, 2 and so on up to q minus 1. Total how many remainders we have here? Q remainders. Number of remainders is q. When p is divided by q, we have number of remainders q. They are 0, 1, 2, 3 and so on up to q minus 1. Q minus 1. So when we performing long division by q, the only possible remainders are 1 to q minus 1. Therefore, the remainder must repeat with at most q minus 1 steps, meaning the maximum possible periodicity is q minus 1. Okay, now Question number 75. Next one. Create a non-terminating, non-recurring decimal representation between 0.1 and 0.2. Create a non-terminating, non-recurring decimal. That means that is a irrational number. When the given fraction, decimal fraction is a non-terminating, non-repeating, then that is known as irrational. Right. Create a non-terminating, non-recurring decimal representation between. That means we should write a irrational number in between 0.1 and 0.2. Irrational number in between 0.1 and 0.2. How many irrational numbers in between 0.1 and 0.2? We have infinity. In that infinity, one irrational number, for example, 0.0, 0.10, 100, 100, and so on. This is a non-terminating, non-recurring decimal. Okay. Right. Now, next question. 76. What is the result when you add or subtract a rational number and an irrational number? Suppose root 2 is a irrational. When we are adding a rational number, that is 3, that can be written as 3 plus root 2. Here root 2 is a irrational, that implies 3 plus root 2 is also irrational. Root 2 is a irrational. It is subtracted from a rational number 3, that gives 3 minus root 2. This is also irrational. So the sum or difference of rational number and irrational number, and 3 plus root 2 or 3 minus root 2. In these both are the irrational numbers. The sum of difference of rational numbers and irrational numbers always irrational. Always irrational. Right. Now, next question, 77. What is the result when you multiply or divide a non-zero rational number with an irrational number? Suppose root 5 is a irrational. Now we can multiply with a rational number 3, that gives root 5 into 3. This is a irrational number. Next, root 5 is a irrational. Now divide with 3, that gives root 5 by 3. That is also irrational. So when we are multiply a irrational number with a rational or divide with a rational, that gives always that is a irrational. ఒక ఇర్రేషనల్ నెంబర్ని ఒక రేషనల్ నెంబర్తో మల్టిప్లై చేసిన, డివైడ్ చేసిన, దాని రిజల్ట్ గివ్స్ irrational. Okay. Now next question, 78. If you add two irrational numbers, is the result always irrational? Give an example. If you add two irrational numbers, is the result always irrational? Give one example. No. The sum of two irrational numbers can be rational or irrational. For example, 2 plus root 3 plus 2 minus root 3 is equal to what is the answer? 4. Here 4 is a rational number. The sum of two irrational number gives a rational number. sometimes the sum of any two irrational number gives rational, sometimes the sum of any two irrational number it gives irrational. Therefore always not true. Therefore our answer is no. No need to a irrational, no need to a rational. Sum of any two irrational numbers is always irrational, not. Okay. So అన్ని సందర్భాల్లో this is not a